we'll talk about how to synthetic divide. Now, typically we would have a polynomial that has many terms in it. And we want to know what x is. So to synthetic divide, let's say we are going to divide by this x plus 3. Okay. Now this x plus 3 means x equals negative 3. All you do is just solve for 3. So technically, let's see if negative 3 is an answer for x. To set synthetic division up, you are going to look at the coefficients and write them down in line using some space. Then we are going to make a little box around it. And I always put a box in the very bottom so that I know that when I'm done. Okay. Then I put this negative 3 here. The first thing you do is bring down your first coefficient. Okay. So this is how you set it up. And I always like to add a little box here to say if we get a number here, we're done, or if we get a 0 here, we know negative 3 is an answer for x. So through synthetic division, you're going to multiply the outside guys together, outside numbers together, so we get negative 3. We are going to add the inside, so that's negative 1. Multiply, it's going to give us a positive 3. Add, multiply, add, multiply, add, and multiply, and then add. So we get a remainder of 1. So what this means is we will have a remaining, when we divide x minus 3, or x plus 3 with this polynomial, we will get the result of x to the 4th minus x to the 3rd plus 9x squared plus 4x plus 8 with a remaining of 1 over the remainder. Okay, so the remaining, since we started out with x to the 5th, we knock down 1 degree and we use those coefficients. You can keep going and divide this by another value, but we do have a remainder to worry about. So let's do this one more time with something that really divides into one another. So one more time, synthetic divide. And this is a great method to do when you don't want to do long division. Long division takes up a lot more space, and here, since we did not get a remainder of 0, we could actually try to find a different x. And that is the synthetic division method when you are doing the rational root theorem and graphing. In other terms, when you have a polynomial that you want to graph and you cannot factor it, this is a great way to find your x's by synthetic division. So let's go ahead and work on this one. Solve for n, so n equals negative 3. We have 1, 5, 1, and negative 15. Place our negative 3, bring down our first number. I'm going to place the box underneath my last constant, or my constant. Multiply, add, multiply, add, multiply, and add. So this means that if n is 3, it will satisfy this equation if you were to set it equal to 0. Then what we have remaining is x squared plus 2x minus 5. And then if you want to find the, or not x, that can be n. I switched my variables around and that's okay. This is supposed to be n. But either way, you can find your other values for your variable by factoring this if it can factor, or using the quadratic formula. But anyway, that's synthetic division. We will use it to graph the other polynomials that we cannot factor.